we are done with the transformation of trigonometric formulas. Now we move on to lesson 6, which is the inverse trigonometric functions of the indefinite integrals, or that is the antiderivative of integrals. So we have here two formulas for inverse trigonometric function, which is the integral of du over the square root of a squared minus u squared, where a squared there is a constant and u there is in terms of x and y, that is the variable. So that is equal to the arc sine of u divided by a plus c if that is a is greater than 0. And the next formula for that one is the integral for du divided by a squared plus u squared, where a there is the constant and u is the variable. So that is equal to 1 over a arctan arctangent of u over a plus c. Okay, so we have here example number 1. So having this one, evaluate the integral of dy over 25 plus y squared. So this, we use the formula of the arctan, which is 1 over a arctan of u over a plus c. So if we are going to have the value of a squared there is 25, which is a is equal to the square root of 25 and a is equal to 5. For the u squared, that is equal to y squared, therefore u is equal to the square root of y squared. So your u is equal to y already. Okay, so substituting the values there, since the derivative of u, which is y, that is equal to dy, and it satisfied the numerator of the equation. So answering this one, let us use the formula that is 1 all over a, which is 5, okay, arctangent of u, which is y, over a, which is your 5, okay. So that is plus c. So that is the final answer for that integral. Okay, example number 2, evaluate the integral of dy over 16 plus 4y squared. Here we use again the formula for arctangent, that is 1 all over a arctangent u over a plus c. So for the value of a squared, that is 16, and if we get the value of a, let us get the square root of 16, which is already 4, and u squared is equal to 4y squared. Okay, to be able to get the value of u there, let us get the square root of both sides, which is 4y squared, and that is equal also to 2y. So if we are going to check, of course, 2y times 2y is still 4y squared. Okay, so having that, but if we are going to get the derivative of u, that is the derivative of 2y, that is equal to 2 dy already. But for our equation, that is only dy, it has no 2 there, so to be able to get that one, we have to manipulate again the equation. So manipulating, it will give us 1/2 the integral of 2 dy all over your 16 there, that is 4 squared already, plus 4y squared, that is 2y raised to 2. So that is equal to 1/2 your a is here, that is 4, and your u is 2y. So substituting that one, it will give us 1 over 2 multiplied by 1 over a, which is 4, the arc tangent of u, which is 2y, divided by a, which is 4. Okay, so that is plus c. Okay, so simplifying this further, it will give us 1 all over 4 times 2, that is 8. Okay, tangent raised to negative 1 multiplied by, for this one, let us reduce this one. 4 divided by 2, that is already 2. So that is y all over 2 plus c. That is the integral for dy over 16 plus 4y squared. Okay, moving on for example 3, evaluate the integral of dy all over the square root of 7 minus 16y squared. So, since that is in square root, the denominator, let us use the formula arc sine of u all over a plus c. So, we get the value of a squared, which is 7, and if we get the value of a, that is just the square root of 7. Okay, so for u squared is equal to 16y squared, and if we get the value of u, let us get the square root of 16y squared, and of course u is equal to square root of 16 is of course 4, and y squared, the square root of y squared, that is y. Since if we are going to multiply that one, 4y times 4y is equal to 16y squared. It's the same. So substituting again the values to the formula, that is already okay. For this one, we get the differential for that one. That is the derivative of 4y is equal to 4dy, and it doesn't satisfy the numerator. Since that is in dy, we have 4 here, so we have to manipulate again our equation. So that will become 1 over 4, okay, the integral of 4 dy all over the square root of your a there is already square root of 7. Since if we are going to square that one, that is I squared is equal to 7. That is minus, okay, your u there is already 4y, and that is squared. Okay, so this one is the value of a, and this one is the value of u. So substituting the values of a and u to the formula, that is also equal to, let us get that one. Don't forget the constant, which is 1 all over 4, the manipulated one. Okay, that is arc sine of u, which is 4y, all over a, which is the square root of 7. That is plus c. So that is our final answer. Okay, moving on to example number 5. We have here the integral of y dy all over 16 plus y raised to 4. Okay, we check again since a squared is equal to 16, and therefore a is equal to 4, since the square root of 16 is 4, and u squared is equal to y raised to 4, and if we get the square root of y raised to 4, that is already y squared. So that is the value for u. But of course, again, the differential of y squared is equal to 2y dy, and this one doesn't satisfy again the numerator, which is y dy, since it has a constant 2 there. So what are we going to do again? We manipulate. That is 1/2 the integral of 2y dy divided by, that is already 4 squared plus y squared raised to 2, which your 4 there is equal to a, and y squared is u. Okay, substituting again the values of a and u to the equation, since we have here 16 plus y raised to 4, and it is not inside a radical sign, we get the arctan for that one. So that will become, that is 1/2 multiplied by 1 over a, which is 4. That is the arctangent of u, that is y squared over a, which is 4. Okay, so that is plus c. Okay, so simplifying this further, it will give us 1 all over 8 arctangent of y squared over 4 plus c. So that is our final answer. That is the integral of y dy over 16 plus y raised to 4. Okay, moving on to example number 6, we have here the integral of y raised to 4 dy all over 16 plus y raised to 10. So we check again the value for a squared, that is 16, and if we get the value of a, that is just the square root of 16, and the square root of 16 is equal to 4, and u squared there is equal to y raised to 10. And if we are going to get the value of u, we get the square root of y raised to 10, and y raised to 10 is equal to y raised to 5 already, since if we are going to multiply y raised to 5 multiplied by y raised to 5, that is just y raised to, we add the indices, which is 5 plus 5. Okay, that is equal to y raised to 10. So that is the value of your u, which is y raised to 5. But of course, the derivative again of y raised to 5 is equal to that is 5 y raised to 4 already, dy, and our numerator is y raised to 4 dy, and it doesn't satisfy again our equation, so we have to manipulate writing that 1 over 5 multiplied by 5, since 5 divided by 5 is equal to 1 also. So manipulating the equation, it will give us 1 over 5, the integral of 5y raised to 4 dy divided by 16, which is that is already 4 squared, plus that is y raised to 5, and that is squared. Okay, to be able to get the integral for that one, let us use arctangent, and that is 1 over 5, let us get the constant, multiplied by 1 all over a, since we are going to use the arctan, that is 1 all over 4, and that is the arctangent of y raised to 5, which is your u, this is your u, this is the a. Okay, that is y raised to 5 all over 4, okay, plus c. So if we are going to simplify that further, that will become 5 multiplied by 4, that is 20 arctangent of y raised to 5 all over 4. So that is plus c. So that is the integral of y raised to 4 dy divided by 16 plus y raised to 10. So we have here example number 7, the integral of sine y dy all over 7 plus cosine squared y. So if we have here 7 plus cosine squared y, we use again the arctangent for this one. So if we are going to check that, we get the value of a squared, which is 7, and a there is already the square root of 7, whereas for u squared, that is equal to cosine squared y, and u is equal to the square root of cosine squared y, that is already cosine y. So since if we multiply cosine y multiplied by cosine y, that is considered as raised to 1, that will become cosine raised to 1 plus 1. We add the indices, which is 1 plus 1, that is already 2y. So it's the same. So the square root of cosine squared y, that is cosine y, but of course we get the derivative of u again, that is the cosine of y, which is equal to negative sine y dy, and this one, it doesn't satisfy again the numerator, since that is in positive, so we have here negative, so we have to multiply it by negative and divide it by -1. It's the same. Okay, that is the negative integral of negative sine y dy, since if we are going to multiply negative times negative, it will bring us back to the original equation, which is positive sine y dy all over, that is already the square root of 7, since that is the value of a, we get the square for that one, since that is a squared. Okay, plus that is cosine y raised to 2. So that is your u, this is the a. Okay, so getting that one, we get again the formula of arctan, which is 1 all over a. So that is 1 all over the square root of 7. Okay, tangent raised to negative 1 multiplied by u, that is cosine y, divided by a, which is the square root of 7, okay, plus c. So that is our final answer for example number 7. Now we move on to example number 8. Let us evaluate the integral of dx divided by 9 e raised to negative 2x minus 1. So for this, we check again the value of a squared and u squared. So if we are going to use the formula, we use the arc sine of u all over a plus c, since this is in it has a radical sign. So checking that one, that is a squared is equal to 9e raised to negative 2x, and of course a there is already. If we get the square root for 9e raised to negative 2x, that is also equal to 3e raised to negative x, since 3 times 3, that is 9, and e raised to negative x multiplied by e raised to negative x, it will give us e raised to negative 2x already. So if we get the value of u squared, that is 1, and since that is u is equal to the square root of 1, that is still equal to 1. Okay, so if we get this one, let us just rewrite the equation, that is the integral of dx divided by, okay, that is the square root of this one is equal to this. So if we are going to rewrite that one, that is 3e raised to negative x, and that is squared. So this one is also equal to 9e raised to negative 2x minus 1 squared. Okay, that is your u, this is your a. So if we are going to rewrite that again, that is dx divided by the square root of, that is 3, since that is e raised to negative x, let us get the reciprocal for that one. Let us put that one at the denominator, and the exponent will become positive instead of negative. So it will become e raised to negative 2x already. So this one, that is raised to 2, since we distribute already the power of 2 there. So that is minus 1, since 1 raised to 2, that is, this is still 1. So we get the LCM for this one, the least common denominator, that is dx divided by the square root of, so the least common denominator for this 1 is equal already to e raised to 2x. This is supposed to be positive already, since we get the reciprocal for that one. So that is e raised to 2x, and that is 3 squared minus, so for this one, that is e raised to 2x multiplied by 1, that is e raised to 2x. Okay, so that is also equal to okay, so that is also equal to the integral of dx divided by, since the square root of e raised to 2x is e raised to x, we bring out that one. So that is already the square root of 3 squared minus e raised to 2x, and that is already divided by e raised to x, since the square root of e raised to 2x is e raised to x, and we get the reciprocal for this one. Let's bring this up. It will become the integral, okay, that is the integral already of e raised to x dx, and what remains in the denominator is still the square root of 3 squared minus e raised to 2x. Okay, so for this, we rewrite again this term, okay, so that is also equal to the integral of e raised to x dx divided by the square root of, since that is already in square, that is 3 squared minus, so for this one, that is e raised to x raised to 2. So this is our a, this is the value of u. So if we're going to check again, the value of a there is equal to 3 and u is equal to e raised to x already. But if we are going to get the derivative of u, that is e raised to x, that is also equal to e raised to x dx. So now it is satisfied already. This one satisfied already the numerator for this one. So we get again the arc sine for that one, that is the arc sine of u, which is e raised to x divided by 3. Okay, the a, that is plus c. So this will be our final answer for number 8, which is the integral of dx divided by the square root of 9e raised to negative 2x minus 1. Okay, so we move on to example number 9. So, if we have here the integral of d beta divided by 6 beta minus 2 minus 9 beta squared, we have here this one. So, if we are going to rewrite that one, let us have here the integral of d beta. Let us put first the b squared there. That it will become negative 9b squared plus 6b minus 2. Okay, so if we are going to factor negative there, that is also equal to the integral of d beta divided by minus. So that is, let us bring factor out negative there, that will become 9 beta squared. Sorry. That is 9 beta squared minus 6 beta. Okay, plus 2. So since if we are going to distribute that one, that is negative 9b squared, negative times negative, that is positive 6b, negative times negative 2, that is negative 2. So it is equal to this one also. So if we are going to rewrite that one, let us bring up negative, since that is already that is negative d beta all over 9 beta squared minus 6 beta plus 2. And this one, it can't be factored. Okay, we can't factor this one, because if we are going to check that one using your algebra, if you remember the your algebra, we use the formula b squared minus 4ac. If that is equal to that is a perfect square, we can already factor this one. But if that is not a perfect square, we can't factor. So if we are going to check this one, that is b, which is if we denote this one 9 as your a, the coefficients, that is b and this is c. If that is b squared, that is negative 6 raised to 2 minus 4 multiplied by a, which is 9, multiplied by c, which is 2. So that is equal to negative 36. We have a perfect square for 36, but for negative, we don't have. So that is not a perfect square. Okay. So if that is the case, we manipulate again the equation. So manipulating the equation, it will give us the integral. So this is not a perfect square. So we can't factor that one. So we manipulate the equation. It will become negative d beta divided by, okay, that is 1 plus 9 beta squared minus 6 beta plus 1. Since if we are going to add 1 plus 1, that is still equal to 2. Since if we are going to check this one, that can't be it can be factored already. So if we're going to check that one, that is b squared minus 4ac, that is equal to negative 6 squared, okay, minus 4 multiplied by 9 multiplied by 2, and that is equal to 0. And that is a perfect square. So the square root of 0 is still 0. So we can factor already this one. So the factor for that is equal to, if we are going to rewrite that one, that is d beta divided by, okay, that is 1 plus 3 beta minus 1 squared, since if we are going to multiply 3 beta minus 1 and 3 beta minus 1, that is 9b squared minus 3 beta minus 3 beta negative 1 times negative 1, that is positive 1. So it will give us the answer 9b squared minus 3 plus 3, that is 6 beta plus 1. So it satisfied already this one. So the factor of that is 3b minus 1 squared. Okay. So getting that one, if we remember that is your a, that is the value of u, but the derivative of the u, which is 3 beta minus 1, is equal to 3d beta. And since this one doesn't satisfy again the numerator, which is d beta, we have to manipulate again the equation since we have 3 there. Okay, so manipulating the equation, it will give us 1 all over 3. Okay, that is minus the integral of 3d beta divided by 1 plus 3 beta minus 1 squared, that is a, that is the value of u. So for this one, we use arc tangent again. Okay, so that is also equal to, okay, so that is negative 1/3 multiplied by the value of a, which is 1 all over a, that is 1 over 1 is still 1. Okay, arc tangent of, that is u all over a, which is 3 beta minus 1 all over 1. Okay, so that is plus c. If we are going to simplify this further, it will give us negative 1/3 the arctangent of 3 beta minus 1 plus c. So that is our final answer. Okay, we move on to example number 10. Let us have this final example. We have here the integral of dy all over the square root of 2ax minus x squared. If we are going to rewrite again the equation, so that is the integral of dy all over, okay, that is the square root of, so we write this one first and then we factor negative there, so it will become negative, that is x squared minus 2ax. So if we are going to distribute negative there, it will become negative x squared. It's the same. And if that is negative multiplied by negative 2ax, that will become 2ax already. So to be able to get the integral for that one, we have to manipulate again, since this one, if you are going to use your b squared minus 4ac, that is not a perfect square. So we have to manipulate that one. So that is the integral of dy all over, that is the square root of, okay, that is a squared minus x squared minus 2ax plus a squared. So since a squared, negative a squared plus a squared is still 0, and we have arrived also again to the original equation, which is x squared minus 2ax, which is this one. So to be able to get that one, since a squared minus a squared is equal to 0, we have arrived at the same x squared minus 2ax. Okay, so if we have manipulated that already, sorry, so that is equal to the integral of dy all over, that is the square root of a squared minus x minus a squared. So if we are going to factor this one, that is still x minus a, x minus a, that is a, okay, that is x times x, that is x squared minus ax minus this one a multiplied by x, that is ax plus a squared. So that is x squared minus 2ax plus a squared. So we arrived at the same. Okay, so that is the factor for x squared minus 2ax plus a squared. That is the factor of that one. That is x minus a squared. And since we have that already, we have here a squared is equal to a squared. So if we get the value of a, that is equal to a, and if we get the value of u squared, that is x minus a squared, so that is u is equal to x minus a, or a already. Okay, so if we are going to use that one, let us use arc sine. The formula of arc sine, that is equal to the arc sine of, okay, that is u, which is x minus a divided by a, which is a, okay, plus c. So that is our final example for the inverse um, trigonometric function. That ends our discussion for lesson 6.